You hear about AI learning all the time, right? But what does that actually mean? I mean, it's not like it goes to school or reads a book. So today, we're going to break down how a machine really learns from its mistakes, and it's probably not what you think. Let's pull back the curtain and look at the surprisingly simple two-part system that powers pretty much everything.
It really all starts with this one simple question. When you or I make a mistake, we feel it. A bit of disappointment, maybe some frustration. It's an emotional thing. But what's going on inside the machine? Does it even know it messed up? And if it does, how?
Well, here's the answer. Absolutely nothing emotional happens. It doesn't feel a thing. Instead, its mistake gets turned into a number, a score. And that single idea, right there, is the huge difference between how we learn and how a machine learns. To put it another way, our learning is, well, it's kind of messy. It's filled with context and intuition and feelings. A machine's learning process, on the other hand, is just pure math. It's this clean, disciplined cycle. Measure the mistake with a score, calculate how to fix it, and then do it all over again, step by step.
All right, so that brings us to the first piece of our two-part system. If a machine needs a score for every mistake it makes, how does it actually come up with that score? Well, it uses something you can just think of as a mistake scoreboard.
Now, the official fancy name for this scoreboard is a loss function. It's just a mathematical rule that takes what the model predicted, compares it to the right answer, and spits out a single number. And that number is called the loss.
But honestly, let's just stick with our idea. It's a scoreboard. That's all you need to know. A high score means the prediction was way off, just terrible. A low score means it was getting close. And the machine has only one goal in its entire existence: get the lowest score possible. That's the whole game.
And this score, it's everything. Without it, the model is completely blind. It has no idea if the changes it's making are good or bad. This one number is the only signal it has to guide it. So the whole point, its entire purpose, is just to make that one number go down.
Now, what's really cool is that the scoreboard actually changes depending on the game it's playing. For example, if the AI is trying to predict a number, like the price of a house, the score just measures how far off it was. But if it's trying to pick a category, like figuring out if an email is spam, the score is way smarter. It's designed to really penalize the AI for being both confident and wrong. The rules adapt to the problem.
Okay, so we have our scoreboard for mistakes, the loss function. But just having a score doesn't fix anything, right? So how does the model actually use that score to get better? Well, that brings us to the second part of our system, the engine that actually drives the improvement.
This whole process is called optimization. Think of it like this. If the loss function is the referee blowing the whistle on a mistake, optimization is the player actually adjusting their technique for the next shot. It's the active process of tweaking all the little internal knobs and dials inside the model to try and lower that loss score.
And really, this is the closest we get to what we think of as learning from mistakes in the machine world. It's not some flash of insight. It's just a calculated adjustment designed for one reason and one reason only: to get a better score the next time around.
So to make this really concrete, let's use an analogy. I want you to imagine you're standing on the side of a huge mountain, but you're surrounded by a super thick fog. Your goal is to get to the lowest point, down in the valley, but you can only see like 2 feet in front of you. What would you do?
Well, you'd probably do something like this. First, you'd take a small step in a random direction. Second, you'd feel the ground under your feet. Is it sloping up or is it slipping down? Third, you take your next step in whichever direction feels the most downhill. And fourth, you just keep repeating that over and over and over. That is exactly how optimization works.
The technical name for this whole walking downhill strategy is gradient descent. Now, the name sounds complicated, but I promise you do not need to know the math. If you can just picture yourself carefully taking steps downhill in the fog, you already understand the core idea behind how almost all modern AI learns. Now, one really important decision you have to make on that foggy mountain is how big of a step to take. This is called the learning rate. See, if you take these huge, giant leaps down the hill, you'll move fast, but you might just jump right over the lowest point in the valley without even knowing it. But if you take tiny, little shuffling steps, you'll be super safe, but it could take forever to get to the bottom. Finding that perfect balance is one of the biggest challenges.
So, a scoreboard and a process for walking downhill in the fog. It almost seems too simple, doesn't it? But believe it or not, this two-part system is the fundamental engine that powers the most sophisticated, most advanced artificial intelligence on the planet today.
So next time you hear that some AI model has been trained on all this data, this is all they're talking about. It is simply run this two-part loop of measure the mistake, then take a step downhill millions or even billions of times until that loss score just can't get any lower.
And this process is absolutely everywhere. It's how your streaming service figures out what movie you'll probably like. It's how a self-driving car gets better at spotting a pedestrian. It's how your email gets so good at catching new kinds of spam. Every single one of them is just playing a game of getting the lowest score possible.
So if you only remember one thing from all of this, let it be this right here. The loss function measures the mistakes. Optimization fixes the mistakes. That's it. That is the core loop of all machine learning.
And that leaves us with a final, pretty fascinating thought. If learning can just be boiled down to a purely mathematical process of minimizing a score, what does that say about what it means to actually understand something? As these systems get superhuman at finding the lowest point in that valley, are they really getting smarter? Or are they just becoming unbelievably good calculators? It's definitely a question worth thinking about.